This is the first lecture for the review concepts for calculus. We're going to talk a little bit about functions. It's kind of where we left off last year. Here we call a function is a rule. Sometimes we call it a machine, where you have an input, which refer to x, going into the rule, and out comes the output, which is the y. So we now have an ordered pair x and y. And with the function, we have a specific rule that says every input or x pairs with exactly one y. And there's a way to look at that graphically, which we'll talk about when we look at graphs of functions. So we have this rule. We have a name of the rule. And that's just the notation or syntax to say I'm looking at rule F. And this is the rule itself. So when I put in 4, it says to take 3 times your input 4 and add on 2, so you get 14. It doesn't have to be just a number. It could be a number and a letter. So in goes 6a in place of x. Simplifying that, adding my like terms, 18a plus 2. In the third example, now it's not just a multiplier. It actually has a difference involved, which would be 3 times b minus 1 plus 2. We end up distributing the 3, and then we would combine the like terms. Negative 3 plus 2 is negative 1. Now we have a sum. Now this involves 2 letters, not a number involved at all, which it really doesn't matter. Whatever my input is, it's going to go into this position. So now I'm going to have 3, and in for x goes this quantity x plus h. And then I need to add on 2 to complete my rule. Distributing the 3, 3x plus 3h plus 2. Now lastly, we have this whole combination, and this is called a difference quotient. It's called a difference quotient, difference for subtraction, and quotient because we have this division involved, and quotient is a division problem. So I'm going to take what I had initially in the problem above, f of x plus h, which we found to be 3x plus 3h plus 2. Then I'm going to subtract my function, f of x, which is 3x plus 2. Notice the parentheses in front of the subtraction sign because I need to distribute that all over h. So simplifying this difference quotient, I get 3x plus 3h plus 2 minus 3x minus 2 all over h. Positive and the negative 2 cancel. The 3x and the negative 3x cancel. And now I have this h and h. So my answer to this entire difference quotient is 3. And if some of you remember, we're subtracting f of x's on top, which is actually subtraction of my y coordinate. Let's just try a couple more examples here. If I have x squared, now I'm looking at a quadratic, and that's going to give me 17. I get 6a plus 1. Now it's wrong or incorrect to put the 2 there. It's all of my input being squared, so it's 36a squared plus 1. In the next example, it's going to be b minus 1 quantity squared plus 1. And what we want to be able to do is expand this fairly quickly. So if I had a cubic or something, I'd want to just be able to write it down. And I'm able to do that using Pascal's triangle or the binomial theorem. If you recall Pascal's triangle, and I'm looking at something squared, those are the coefficients. So it's going to be b squared minus 2b plus 1 plus 1. This is the expansion of b minus 1 times b minus 1. I could have taken b minus 1 times b minus 1 and used my distributive property and also got the same result. But Pascal's triangle speeds things up a little bit. So again, if I want to simplify that, that would end up being a 2. Now we're down to this x plus h. This is a huge concept coming up in Chapter 2 of Calculus on functions. And so what we're going to do with this is the same thing we did over there. I'm going to get x plus h squared plus 1. Now the problem is x plus h quantity squared is not complete. Again, you've got to take x plus h times x plus h because of the exponent. If I use Pascal's triangle, my coefficient of 1, x squared plus 2. Remember, x decreases in power, h now comes in, and then lastly, x goes away in power, and h comes in. And so that would be my expansion, and don't forget at the end, I would have to add on 1, and I would be complete at that point. There's nothing else I can do. Now, shortcutting this a little bit, notice these are the same, so I've just done that once. Why would I need to repeat it? I'm going to put it into my difference quotient, which is x squared plus 2xh plus h squared plus 1. Then I'm going to subtract my function, which was x squared plus 1, and I would divide this all by h. Well, lots of things are going to cancel, and this should happen every time, and you'll have a few of these in your practice homework. The x squareds cancel, positive and negative 1 cancels. Notice, now you're reducing fractions. You have 3 terms, and there's an h in every term. There's an h in every term, and so if I'm canceling one of those, I get 2x plus h. That is my difference quotient. Notice the h in the denominator is entirely canceled. Let's try one more with a cubic here. I'm going to get 4 cubed plus 2 times 4. In this case, I'm going to get 6a quantity cubed plus 2 times 6a. Again, distribute and use your exponent properties. Okay, how do I take quickly and easily x plus h, cube it? Well, again, I'm going to use Pascal's triangle. And Pascal's triangle tells me that I know my coefficients. If I'm doing a cube, I'm looking at a cube, I'm going to run down to this row, 1, 3, 3, 1. And then notice the powers on the x and the h. So it's going to be 1x cubed plus 3x squared h plus 3x h squared. Notice h and x decrease and increase in powers. And lastly, I get 1h cubed. So I've completely cubed that without really having to write that down, knowing Pascal's triangle. Distributing the 2, I get a 2x plus a 2h. So again, to shortcut this process, this quantity is right there. So I'm going to repeat, multiply it down. It looks like I can't combine any of those. So I get x cubed plus 3x squared h plus 3xh squared. Recall the binomial theorem and what it did to powers and your coefficients. Now I'm going to subtract the function. And if I recall, my function was x cubed plus 2x. That's incorrect, because I need to remember to subtract the entire function, not just part of it. All of this is divided by h. Distributing by negative, x cubes are going to cancel. Remember, lots of things are going to wipe each other out here. Now, everything has an h. 1, there's 3 here, so I'm going to end up with 2, and there's 1 here. So my end result for this problem is going to be 3x squared plus 3x h squared plus h squared plus 2, all over 1, because my h's cancel. And that would be what we call the difference quotient.